To see grid resilience and self-healing networks, enhancing power systems, reliability and stability. Hello everyone, my name is Rohanala. Let's dive into the topic. Introduction to grid resilience. It's an ability of power grid to withstand, adapt, and recover from disaster. Importance: protect against natural disaster like storms, earthquakes, or heavy rain, or a tree fallen on electric circuit. Reduces downtime and economic losses. We will try to reduce the downtime if there is any tree fallen on an electric circuit. It's a downtime of the electricity. Then we will try to reduce that by alternative way. Ensure continuous power supply for critical services. We will try to supply the power supply to critical service like hospital and etc. by an alternative way. Key focuses reliability, adaptability, and rapid recovery. What are self-healing networks? It's a power grid that detect, isolate, and automatically recover from faults. Core features: real-time monitoring and grid conditions. Yeah, in a real time, it will try to monitor all the circuits and it will check if is there any error or any fault, anything. In automatic fault detection, if there are any circuit and it is let's say it has switch 1, switch 2, and switch 3, and will there is any fault between switch 1 and switch 2, it will automatically detect and isolate switch 1 to switch 2 circuit so that others cannot be get affected. Dynamic rerouting of power to unaffected area. If there is an error or any fault between switch 1 and switch 2, then it automatically reroute the electricity to switch 3 so that unaffected area should get the electricity so that it will make more utilization of power supply. Restoration without human intervention. Here, there will be no intervention of the humans because it is done by a network in an automatic way, so that it will done in in a seconds, less than a seconds. If in a traditional way, if there is any electric cut, then we'll call an electrician. Then he'll come, he'll try to fix the fault, and it will take hours together. It may take days, but here it will try to reduce the power cut in a seconds by alternative way, and it will, after that they will try to correct the fault, and the goals are minimize outage duration and maintain service quality. As I said, it will reduce the outage duration and maintain a better service quality. Now we'll see an animated video.
A self-healing grid is one capable of automatically sensing, isolating, and instantaneously responding to power system disturbances. This is made possible by implementing smart sensors, intelligent switches, advanced communication, and distributed generation into the grid. In order to communicate real-time information, smart sensors and switches are placed along power lines and in power substations, which can detect trouble and automatically diagnose problems on the line and reroute the power accordingly. This animation depicts a self-healing system procedure. We can see a community made up of residential, business, and critical need customers. Here, homes, school, shopping center, and hospital all are receiving electricity from power source A, whereas power source B serves the other section of town. Now notice switch 1, switch 2, and switch 3. These intelligent switches can automatically detect trouble on the lines and then stop, start, or reroute the power in order to isolate the problem. Let's take a look on what happens when a tree falls on utility pole due to a storm, resulting in a damaged pole and power line. As per today's technology, energy source A would shut down and the entire community, including the shopping center, homes, school, and hospital, will lose power. In fact, they would remain out of power until a customer notifies the utility and crews are sent to make repairs. On the other hand, with the use of smart sensors and control technologies, switch 1, switch 2, and switch 3 immediately detect the problem. When the tree hits the pole, switch 1 senses an abnormal power flow caused by the damaged power line. Switch 1 then communicates with switch 2 and 3, and switch 1 and 2 open up to stop the flow of electricity and isolate the section of line between them. Power source A is now providing electricity to the shopping center. Further, switch 3, which is normally open for power source A, closes in order to provide electricity from power source B. Power source B is now rerouted to deliver power to the remaining community. Power continues to flow in most areas, including homes, school, and the hospital. Only the customers served between switches 1 and 2 lose power. While this animation has been slowed down to allow you to see a series of events, this self-healing process would actually happen in less than a second. In fact, customers may notice only a brief blinking of the lights as the smart grid automatically isolates the outage and keeps power flowing to the greatest number of customers. This outage would be automatically communicated to the utilities power delivery work center by the smart grid, which can quickly send a repair crew to the area. As soon as the repairing is finished, Power Delivery Works Center remotely restores the power flow to its original state.
I will see benefits and future outlooks. Benefits, it will reduce outage and faster recovery, as you can see in the animation. Will reduce the outage and improve the faster recovery. Improved integration of renewables. You can also add renewable energies like solar energy and etc. Lower operational cost as compared to traditional way. It is lower operational cost because it's automatically sensed. Enhances safety and reliability. You will enhance the safety in a fault area so that no people should get affected and reliable to other people who are not unaffected. In future trend, we can add AI driven smart grids, microgrids, and distributed generations, and IoT and edge computing for better monitoring, so that we can add AIML. So automatic sensing is done, and we can improve our service by faster way or in a good way. So that's all. Thank you for your patience.